Welcome to springlib.
Let's follow this construction. We put B0 to be the empty set. Now from A minus B0, we take some element in some way, let's say randomly, an element x1. Of course, B0 is empty, so when we remove nothing from A, we're just left with A, and A is an infinite set. So, well, there are infinitely many elements. Let's just take one. Let's call it x1. Then we put B1 to be the set that only contains this element x1. Now, from A minus B1, again, we take in some way an element x2. Again, A has infinitely many numbers, elements, and we're not considering the elements of B1, which is just x1. So, well, from infinitely many, we just remove one, so there are still infinitely many. So we can take an x2, say. And then we put B2 to be the set that contains x1 and x2. And we keep repeating this process. From A minus Bn, we can still take some element because Bn is going to be finite, and so A minus Bn is going to be infinite. So there is something. This means that this process never stops. Because every Bn, again, is finite. It contains exactly the elements x1, x2, all the way up to xn. And so A minus Bn is still infinite. So there must be something in A minus Bn, which means that we can take another element. Now we have the sequence of sets B1, B2, B3, which essentially means we have a sequence x1, x2, x3 all the way up to infinity because the process never stops. So formally we write the set big B as the union of these sets Bn, but that just means that we're taking the set that contains x1, x2, x3, and so forth, which is an infinite set because the process never stops, and is countable because, well, we have an enumeration. We have x1, x2, x3, so, well, there's a projection with z plus where xn goes to n. And so this set big B is a subset of A and is countably infinite, as we wanted to see.